All right, so today what we're doing is we're finding x-intercepts of quadratic functions. This is stuff we've already done, okay? You already did this in Algebra 2. What this is a quick review of the things that we did in Algebra 2 in regards to quadratics. Does that make sense? So it's not going to be drawn out. We're not going to spend weeks on it like we did in Algebra 2 because we already did it. But we are going to reiterate some of the things about factoring, using the solving for x, using completing the square in the quadratic formula, okay? So if you look up here, the first problem that we have is f of x equals x squared plus 5x minus 50, okay? We want to use the quadratic. We're going to find the zeros of the quadratic by factoring. This is an example of a simple factor. The reason why it's called a simple factor is because your a equals 1. So when your a equals 1, you're going to start off by asking yourself what multiplies to give me my c term, but adds to give me my b term. Oh my gosh, I forgot to write your forms. So across the top, we're going to write the 3 different ways of how to write a quadratic. So first, we have y equals a, or not, ax squared plus bx plus c. Then we're going to write y equals, that's our standard form. Then we're going to write it in vertex form, bless you, a times x minus h squared plus k. That's our vertex form. H and k are our vertex. And then our last form that we have is our root form or our factored form, y equals a times x minus root 1 times x minus root 2. Okay, a key thing to remember are that your x's are liars. So even though it looks like they are negatives, they're actually positives, okay? All right, so back to the problem now that we are informed. So to remember standard form, A, B, C. So we're asking ourselves what multiplies to give us our C term, but adds to give us our B term. So what 2 numbers multiply to give me negative 50, but add to give me 5? 10 and negative 5. So therefore, my factors are x minus 5 times x plus 10. So this is from standard to factor. Do we see that? Okay. Because it says list out the x-intercepts of the graph of the function, that means you're taking each factor and setting it equal to 0. Because x-intercept means your y equals 0. So if I take x minus 5 and set it equal to 0, and I take x plus 10 and set it equal to 0, what are my x-intercepts? X equals 5 and x equals negative 10. So these are where my x-intercepts would lie. Does that feel familiar? Yeah? Okay, cool. So I was like, I've never seen this before. Next is when your a is greater than 1. So when a is greater than 1, or not equal to 1, I should say. When a is not equal to 1, this is where we do the box. If I say X box, does that ring any bells? X box or completing the square, I mean, not complete square. So with X box, so our X, you're asking yourself what multiplies to give you 2x squared times negative 7, which is negative 14, but adds to give you negative 5. So it multiplies to give you negative 14, but adds to give you negative 5. What 2 numbers? Negative 7 and positive 2. Agreed? So you can double check. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So both are satisfied. Okay. After we do X, we can then go into the box. You don't have to do the box. You can always go into grouping, but the box helps you stay a little more organized and it takes up less space, I think. So in the box is always your first term, 2x squared, and your last term. And then you're going to put in your numbers that you found. We found negative 7x, and we have positive 2x. Okay. The key with the box is you're finding the GCF of everything. What is the GCF? Greatest common factor. So I'm looking for what is the GCF between these 2 numbers? With 2x squared and 2x, 2x. What is the GCF between these 2 numbers? -7. What is the GCF between these two numbers? X. What is the GCF between these two numbers? 1. So therefore, your factors here are x plus 1 and 2x minus 7. Does this look familiar, ringing bells? Okay. So this will be in factored form. And then from there, I can set each one equal to 0. If I was set this equal to 0, what would x be? X equals -1. If I set this equal to 0, what would x be? 7/2. Because I would have to add 7 and divide by the 2. Okay. 1 and 2, what are your questions, comments, or concerns? None? Good, we feel good? Okay, cool. Next, finding zeros when you only have x in one term. When you're finding zeros with x in one term, the key thing to remember is that you're setting it equal to 0. So if you're looking for your x-intercepts, you're just setting it equal to 0 and you're solving for x. So I'm going to give you a moment to get x by itself and these 3 problems. Okay, so try independently to get x by itself. Okay, so here we have solving. So hopefully you solve. Number 1 is a 2-step solve, right? In order to get x by itself. So when we're solving to get x by itself, remember the goal is you're undoing everything, right? Called inverse operations. So if I have a -4, I'm going to add 4. So hopefully you did that. After I add 4 to both sides, I'm left with x squared equals +4. Then I'm going to take the square root, because the opposite of squaring something is to square root. The key thing to remember is when you take the square root, it produces a positive and a negative solution. Okay, so your answers would be x equals +2 and x equals -2. Okay, so this is an example when you have a perfect square. Well, what do you do if you don't have a perfect square? Let's see. So if I have x squared minus 11, I'm going to add 11 still, following the same protocol. And I'm going to be left with x squared equals 11. Then I'm going to take the square root of x squared. And because even though it's not perfect square, it's still going to produce a positive and a negative square root of 11. So therefore my solutions are x equals positive square root of 11 and x equals negative square root of 11. Okay, the last one is in vertex form. So in vertex form down here, we're going to add 25 because we're undoing, working our way to get x by itself. So that's x minus 7 squared equals 25. Then we're going to take the square root. And we're left with x minus 7 equals ± 5. Because the square root of 25 is positive or -5. X is still not by itself, so the last thing I have to do is add 7 to both sides. When we add 7 to both sides, it becomes 7 ± 5. Okay? A plus or minus means I have 2 operations to follow. I'm going to have to do 7 plus 5, and I'm going to have to do 7 minus 5. That gives us 12 and 2 are what x equals. Okay? Does 3, 4, 5 ring any bells? Yes, no, maybe so. We're good? Yes. Okay. Next, we have completing the square is the other method that we learned on how to solve for x-intercepts. So when you're completing the square, there are 6-ish steps that we have to solve. So step 1 is you want to make sure that a equals 1. If a doesn't equal 1, then you divide everything by a. Okay, that's going to be step 1 we follow. Then after that, step 2, you want to move your c. After we move our c, step 3, we're going to find our magic number. Okay, to find our magic number, it's our b divided by 2 squared. Step 4 is to add the magic to both sides. If I only add it to 1, then it won't be staying equal. Step 5 is to factor and simplify. I'm going to apologize because I did not leave you enough room in hindsight. And then step 6 is to solve for x. So these are going to be the 6 steps that we follow to solve this problem. So step 1 is you want to check that a equals 1. Does our a equal 1? Yes, so we're good to go. Step 2 is to move our c. What is our c? 45. So how do I move a positive 45? I'm going to subtract it. So we're going to be left with x squared minus 14x equals -45. Step 3 is to find our magic number. Well, what is our b value? negative 14 divided by 2 squared? What is negative 14 divided by 2 squared? 49. Step 4 says to add the magic to both sides. When I add the magic to both sides, I have x squared minus 14x plus 49 equals negative 45 plus 49. Step 5 says to factor and simplify. So what multiplies to give me 49, but adds to give me 14? It'd have to be a negative 7, right? And it's gonna be 2 of them. So can I just write it squared? Yeah, because it'll be x minus 7 and x minus 7. So I can just write it as squared. And what's negative 45 plus 49? 4. And the last and final step is to solve for x. So what takes place in order for me to solve for x? Square root. So I'm going to have to take the square root of 4. And that's going to do what? It makes a positive or negative. Sorry, I didn't write it there. Kind of need the rest of it here. So we have x minus 7. And then what's the last thing I need to do? Add 7. So now we're left with x equals 7 plus or minus. And what's the square root of 4? 2. What does the plus or minus tell me? There's 2 outcomes. So my first outcome is 7 plus 2, which is what? X equals 9. My second outcome is 7 minus 2, which is x equals 5. So that's how completing the square works. I know. That's why I said I apologize for number 7. We have no room for number 7. I just wanted to show you really quick what it means when it says to multiply by a. So I mean divide by a. So notice here how on number 7, we have a doesn't equal 1. So we would divide everything by 6. So we would really be working with x squared plus 1/2 x minus 1/2. And then you'd go through the rest of the steps. Does that make sense? Okay, that's what it means to divide. I did not leave us any room to do this problem on our notes. So we're just gonna keep pushing. Is that cool? All right. Apologizing again. All right, on to the next part of our notes is reviewing the quadratic formula. If you remember it, sing along. If you don't, write it down. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's the quadratic formula. Okay. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right. So how does that work? Well, you just plug in everything you know, right? So you're going to plug in your a, your b, and your c, and go from there. We're going to do 8 together, and I'm going to let you do 9 on your own. Cool? So example 8, we're going to plug in. So this is my a, my b, and my c. So I have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? And then now you're just going to start simplifying. All right? So now we're at the simplifying. You plug in and then simplify. A negative times a negative is a positive. So we have 45 plus or minus, and I have my whole square root to put in. So I'm going to put in negative 45 squared minus 4 times 7 times negative 28. If I don't have a graphing calculator at home, could I put it in parts? Yes, you can. But if you have a graphing calculator, mine's closed out. Gonna bring her back. There it is. So I'm gonna put in parenthesis negative 45 squared. And I like to put everything as is. So 4 times 7 times negative 28. And underneath my square root, I get 2,809. So underneath my square root, I have 2,809. Okay. B squared minus 4AC. Okay. All over. And 2 times 7 is 14. Okay. So I need to find the square root of 2,089. So second square root 2,809. And I get 53. So now I'm left with 45 plus or minus 53 all over 14. That plus or minus tells me that I'm going to have what? Two outcomes, right? I'm going to have 45 plus 53 divided by 14. And I'm going to have 45 minus 53 divided by 14. So I'm solving two things. So I have x equals 45 plus 53 divided by 14. So I have 45 plus 53 divided by 14. And that gives me 7. So my first x equals 7. My second x is going to be x equals 45 minus 53 divided by 14. 45 minus 53 is negative 8. I get negative 8 over 14. Can I reduce that? Yes. What is negative 8 over 14 reduced to? 4 over 7. So here's my final x. Okay. The quadratic formula is your catch-all. If you're not good at factoring or good at completing the square, the quadratic formula is going to work every single time. Does that make sense? So we learn the other methods, but if all fails, you have the quadratic formula. Okay. All right. So I would like for you to do number 9 until the bell. And then when we come in tomorrow, we're going to pick up at number 10. All right, guys, the bell's going to ring, so I just wanted to give you a chance to check yourselves. All right, so when you did the math, hopefully you realized that your A was in the correct order, but your B and your C were switched, okay? Remember, B is always with X and C is your constant, okay? So then when you plug them in, you simplify, you should end up with X equals 3 plus or minus the square root of 85. Why did we leave it as square root of 85? It's because it can't be simplified, right? It's just there, okay? Divided by 2. So that's what your answer should have came out to be. That is the final answer. You can't simplify anymore. All right, so tomorrow we will finish finding the intersection algebraically, and then after that you will have classwork to do.